Hello everyone, welcome to Vision Tech Solutions channel. In this video, I'm going to talk about the Ether channel or port channel. And first, I will have an introduction about the Ether channel, and then we are going to have a lab which explains how Ether channel works, and we will do the configuration with regard to different modes of Ether channel. So first of all, what is Ether channel? Suppose we have two switches in our company, and these two switches are connected with Ethernet link, and this Ethernet link has 100 megabit per second bandwidth. And as our company grows and we need to maybe transfer more data, and also we want to add resiliency to our network in case one link fails, we want to have another like a redundant or a backup link. So in this case, we will another link to our switches, like two links. But the issue is when we add another link, one of them will be blocked because of the spanning tree protocol, which is a mechanism for preventing the loop in the network. So it will block one of the ports because of the STP protocol. So what is the solution in this case? If we want to utilize both links and at the same time we don't want any links to be blocked, and also we want to have redundancy in case one link fails. So the solution is Etherchannel. Actually, by Etherchannel, we bundle the physical links into one logical link with the combined bandwidths, and it will increase the bandwidths. At the same time, we will have redundancy as well. So if you look at this picture, we bundle these two links. Suppose two links which we had previously each 100 megabit per second. Now two links, we will have 200 megabit per second, and actually we will have also redundancy. So it means we have combined, or we have bundled these two links into one logical link, which is called the Ether channel, and we will utilize both links bandwidths, and also we will have redundancy. So as I said, that's a physical, that's a logical actually interface, and we have three mechanisms for the Ether channel, or actually we can say we have three protocols. One of them is PAGP, or port aggregation protocol. One of them is LACP, which is the industry standard protocol, and one is like the static. It's not using any protocol, it's just a static protocol. And of course, PAGP is a Cisco proprietary protocol. It's only for Cisco, it works only for Cisco devices. And LACP is the IEEE standard protocol. So the PAGP, or port aggregation protocol, which is the Cisco proprietary protocol, it works in two modes, an auto and desirable. In the auto mode, it will respond, the switch will respond to the PAGP messages, but doesn't aggressively negotiate a PAGP Ether channel. A channel is formed only if the port on the other end is set to desirable. So this is the default mode, is actually the auto is the default mode. And desirable port actively negotiates channeling status with the interface on the other end of the link, and the channel is formed if the other side is auto or desirable. So if we look at these modes, PAGP, we have desirable auto, so it can be desirable on auto. So if one side is desirable, the other side is either desirable or auto, it will work. If one side is auto, the other side is also desirable, it will work. But auto will not work. So if you configure both sides of the link as auto, it will not work. It should be either desirable or desirable auto. For link aggregation, link aggregation control protocol, or LACP, which is the industry standard protocol. We have two modes, passive and active. For active, it responds to the LACP messages but doesn't aggressively negotiate LACP at the channel. And a channel is formed only if the other end is set to active. So we cannot have passive and passive. For active, port actively negotiates channeling with the interface on the other end of the link. A channel is formed if the other side is passive or active. So we look at this table. So LACP, if one side active, yes, the channel will be formed. Active, passive, it will be formed. Passive, active will be formed, but passive, passive, so we cannot have passive and passive on both sides. And the other one is the static. So static means we are not using LACP or PAGP any protocols. We just no negotiation is needed. It will be on. An ether channel will be formed immediately. And when using this mode, we have to make sure the other end must use this mode too. So we cannot have on and PAGP or LACP or active desirable or auto on the other side. If it is on, both sides should be on. And also some configurations should match, like speed settings, duplex settings, STP settings, VLAN membership, native VLAN, allowed VLANs, and trunk encapsulation. And Ether channel will not form if either dynamic VLANs or port security are enabled on the participating Ether channel interfaces. So it is not usually recommended to use on. We usually use LACP, which is the industry standard protocol. Now let's go to the lab. So the lab, in this lab we have 4 switches: switch 1, switch 2, switch 3, and switch 4. As you can see, I have 4 switches. So right now let's look at the ports status on all switches. And of course I have not configured the LACP, and we have redundant links, so one of the links from each switch to the other one will be blocked. Let's go to switch 1 and check and we have only one VLAN. So to check if the traffic is forwarded on which links, I issue the command show spanning tree for VLAN 1, because we have only one default VLAN, VLAN 1. So as you can see in switch 1, we have fast Ethernet 1 and 2 going to switch 2, fast Ethernet 3 and 4 going to switch 3, and 5 and 6 are going to switch 4. So it is forwarding on all interface. It means this route, this bridge or this switch is the route. That's why it is forwarding on all interfaces. But the other, as you know, in previous videos I explained about the STP and how it works. It will automatically block some ports in order to prevent loop in the network. So one port will be the designated or the root port, which will be put into forwarding, and the other one will be blocked. Now if we can go to switch 2 and verify this. So if I go to switch 2 and issue the command show spanning tree VLAN 1, so port 1 and 2. Port 1 is the root port, so it is in the forwarding. So this is the root bridge and this is the root port, and the other one, as you can see, it is blocked. The other one is blocked. Now I want to configure the LACP. First I will configure the Etherchannel LACP. So bundle these two ports together using the LACP protocol and see, and then we will verify that the traffic will be forwarded on both links, or we actually convert these two physical links into one logical. So first I will go to switch 1. I will go to both interfaces, fast Ethernet 1 and 2. I issue the command channel group. I put number. I assign a number for the port channel or the logical interface, and for LACP it should be either active or passive. Active one side or passive on the other side, or active. I put active. Now if I go show IP interface brief, I will see that one logical interface is created. So I go to int port channel 1 and I put, then I can switch port. I can change the mode of my logical interface to trunk. So now show Etherchannel summary to check the status of the. So S means it is a layer 2, actually layer 2 Etherchannel. Then in the next video we'll explain about layer 3 Etherchannel as well. So it means it is not these ports still, the Etherchannel is not formed, and D means down. Etherchannel is down because I haven't configured switch 2. I haven't configured switch 2. P, it should be P, participating or in the port channel. If it shows P, it means in the port channel. I, standalone, it means they haven't formed the Etherchannel yet, because I haven't configured on the other side. Okay, now I go to switch 2. I will do the same. Int range 0, 1 to 2 and channel group 1 mode. So this on switch 2 I put passive, int PO1 and switch port mode trunk. Now if I issue the command show Etherchannel summary, and you can see that the Etherchannel is up and both are participating, fast Ethernet 1 and 2. So it means none of these ports are now blocked. How can we verify that? Show spanning tree VLAN 1, and it is still in the learning phase for channel 1. So as you can see now, it is forwarding, and port channel 1 is actually a logical interface that represents fast Ethernet 0, 1 and 2. So it is forwarding now on both links. So actually these two switches think that there is only one link, which is actually a combination of two physical links. If I go to switch 1, show Etherchannel summary, and as you can see that the port channel is up, U means up, and both are participating. Now I want to show you how to configure the PAGP. Show spanning tree VLAN 1. So 5 and 6, ports 5 and 6 are going to switch 4. So 5 in switch 1, as we know, all the ports are in the forwarding state, but if I go to switch 4, show spanning tree VLAN 1. So as you can see, 5 is the root port, and so the root port, and it is in 5 and 6. Actually 5 should not be in the blocking. Let's see. Okay, both are so show IP interface brief, show run. Let's see if we have any configurations. Conf t int fast 0 or int range fast 0 5 to 6 shut no shut. Show spanning to VLAN 1. Okay, 5 is listening, as you can see. Learning. It will take some time to change status. Okay, so as you can see now, port 5 is forwarding and it is a root port, and 6 is blocked. 6 is blocked and 5 is in the forwarding state. So between 5 and 6, 6 is blocked. So I will configure the PAGP. Now I'll go to switch 1. Int range fast Ethernet 0, 5, and 6. Channel group, so I put number 2. Mode, it should be auto and desirable for PAGP. So auto. Then I go to int port channel 2 and switch port mode trunk. Now show Etherchannel summary. So as you can see, the mode Etherchannel 2 mode PAGP, but still it is down because I haven't configured on switch 4 yet. So I go to switch 4, int range fast Ethernet 0, 5, 2, 6. Channel group 2 mode, I put desirable, and int port channel 2 and switch port mode trunk. Now show Etherchannel summary, and you can see that the PAGP between switch 1 and switch 4 is up and they are participating. Now show Etherchannel summary, and you can see that show spanning tree VLAN 1, and as you know, so we have bundled 5 and 6. You don't see 5 and 6, and it is forwarding the traffic on port channel 2 because now we have bundled, we have one logical interface. We have one logical interface. And lastly, let's go and check switch 3. So switch 1, as you know, all the ports are in the forwarding, but in switch 3, show spanning tree VLAN 1, port 3 and 4. Of course, I have to flap the links. I think there is one issue here. Int fast Ethernet 0, 3, and 4. Int range shot no shot. Show spanning tree VLAN 1. So to give it some time for the spanning tree to converge. Okay, it's going to the listening, learning, and then will be forwarding. Okay, now it is fast 03 is forwarding, but 4, as you can see, 4 is blocked. So one is root port, one is blocked. So conf t. Now I want to configure the static Ether channel. So int range fast Ethernet 0, 3, 4, and channel group. Let's put 3, mode on, and int PO3 switch port mode tronic. Now show Ether channel summary. It shows up, and as you can see, there is no protocol because I'm using the static Ether channel. Now if I go now to switch 1, because I haven't configured on that side to show Ether channel summary, as you can see, I don't see port channel 3, so I have to configure int range fast Ethernet 0, 3 to 4, channel group 3 mode on, and int PO3 or port channel 3 switch port mode trunk. Now if I show Ether channel summary, and I can see that it doesn't show any protocol because I'm using the static, and these two ports are participating and it's using port channel 3. Now if I go on switch 3 and show spanning tree VLAN1, you don't see port 3 and 4 because I have bundled them to one port channel, which is the root port. So in this lab, we configured 3 different modes that we have for Ether channel or port channel, which was LACP, PAGP or static one, and I showed you how we can configure the Ether channel in order to bundle the ports and utilize the overall bandwidth of both links at the same time, and also we can have redundancy in our network. I hope this lab has been useful, and see you in the next lab. Thank you.